In this lesson, we will learn about autonomous IP architecture. Let's first learn about the definition of autonomous IP. An autonomous IP has full set of wireless functions such as RF, transmit and receive, encryption, channel assignment, client authentication, and so on, which means an autonomous IP can provide the wireless service on its own without any additional devices. An autonomous IP also has Ethernet port to connect to an Ethernet network to allow mobile clients to communicate with cable clients. Therefore, an autonomous IP acts as translational bridge to convert frames from two dissimilar media, wireless H.02.11 frames and Ethernet H.02.3 frames. In this wireless network, this IP is an autonomous IP because it can provide the wireless service and it also have the Ethernet connection to connect to this Ethernet network. In autonomous IP architecture, to provide wireless service, each autonomous IP is configured with an SSID. To separate the network traffic for wireless clients, additional SSIDs can be configured as needed. Each SSID is assigned with a VLAN. To be remotely managed, the IP must be configured with a management IP, which usually belongs to the management VLAN. To allow wireless clients to communicate with cable clients, each autonomous IP must be connected to a switch via a chunk link, and the chunk link must be configured to allow the VLANs configure on the IP. If a switch is configured with the same VLAN assigned to the SSID, wireless and cable clients of the same VLAN can communicate with each other at layer 2. For the clients at different VLANs, a layer 3 device is required to route the traffic between VLANs. Let's now move on to cloud-based architecture. IPs in the cloud-based architecture are autonomous IPs. Therefore, the access points and the switch infrastructure are configured the same ways as configured in the autonomous IP architecture. However, all the wireless configuration parameters such as channel assignment, transmit powered, SSIDs, authentication, and the corresponding VLANs are configured centrally from the Meraki cloud server. To get the configuration from Cisco Meraki Cloud, the cloud-based IPs must have the access to the Internet. The IPs must be registered with Cisco Meraki Cloud. When a cloud IP powers up, it will contact the cloud via the Ethernet connection that allows it to access to the Internet and download the configuration from Cisco Meraki Cloud. Let's install and configure wireless network for this network diagram. Here are the steps that we're going to do it. First, we need to connect the IPs to the switches via chunk links. Then we configure wireless network for steps with the SSID IT life skill stuff and assign it with VLAN 10. To separate wireless network traffic for steps and guests, configure another wireless network for guests with the SSID IT life skill guest and assign it with VLAN 20. To remotely manage the IPs, Each IP is configured with an IP address that belongs to the management VLAN 1. To allow the wireless traffic to flow on the switch infrastructure, all the chunk links must allow VLAN 10, 20, and VLAN 1000. To allow wireless clients to access the Internet, the Layer 3 switch infrastructure must be configured to forward the traffic from VLAN 10 and VLAN 20 to the Internet. To allow wireless traffic from IT life skills staff to access production servers in VLAN 1000, the Layer 3 switch infrastructure must be configured to provide the routing between VLAN 10 and VLAN 1000. Let's analyze network traffic to see how it flows in this network. To do that, we have three laptops, A, B, and C, to join to the IT Life Skills Staff wireless network. When laptop A communicates with laptop B, the traffic flows at layer 2 via the access point. When laptop A or laptop B communicates with laptop C, the network traffic flows at layer 2 through the switch infrastructure and between the two access points. For any of the laptops to communicate with the production server or to the internet, the network traffic flows at layer 3.